Hello, my name is Muhammad Daniel Shafi'i. My matrix number is 07DTP23F1011. Today, I will present about 3D design of mold in tool design. Firstly, introduction. Plastic injection molding is a high-volume manufacturing process that involves melting plastic pellets and injecting the molten material under high pressure into a mold cavity. The molten plastic cools and solidifies within the mold, which contains the shape of the final product. Once the part is solid, the mold opens, the part is ejected, and the cycle repeats to produce identical plastic part quickly and efficiently. The next is objectives. Firstly, to design a 3D model of an injection molding system using CAD software. Second, to understand and apply the principles of injection molding, including material flow, mold design, and part formation in a practical 3D design. Next, to develop a functional and efficient mold design that minimizes material waste, production time, and manufacturing costs. Next, to enhance technical design skills in 3D modeling, assembly, and rendering of mechanical components related to plastic manufacturing. And lastly, to evaluate the sustainability and environmental aspects of mold design by considering recyclable material and energy efficient production. So now we move to injection mold in plastic process. Injection molding uses a special purpose machine that has three parts: the injection unit, the mold, and the clamp. Parts to be injection mold must be very carefully designed to facilitate the mold process, the material used for the part, the desired shape and feature of the part, the material of the mold, and the properties of the molding machine must all be taken. So this is injection mold in plastic process. Firstly, we have injection molding. Injection molding used for produce part by injecting molten material into a mold. Once inside the mold, the hot plastic cools and hardens to take the shape of the cavity. When the plastic has solidified, the mold opens and ejector pin push the finished part out. Second, transfer mold. Transfer molding, the material is placed into a heated transfer pot and then pushed by a plunger into a closed mold cavity through small channels. The material cures under heat and pressure, and once it solidified, the mold is opened and the finished part is removed. Excess material is then trimmed off. Next is extrusion. In extrusion, plastic pellets are melted in a heated barrel and pushed by a rotating screw through a shaped die to form a continuous product. The hot material is then cooled and cut into the desired lengths, producing items like like pipes, tube, and plastic sheets. So lastly, blow molding. In blow molding, heated plastic is formed into a hollow tube that called a parison. Air is then blown in the parison, forcing it to expand and take the shape of the mold cavity. Mold open and the hollow product was done. So now we move to injection molding defects. Firstly, we have short shot. Short shot is an injection molding defect where the molten plastic doesn't completely fill the mold cavity, resulting in an incomplete part. It is cause of low pressure, insufficient material, and blocked gates. So now we move to injection molding defects. Firstly, we have short shot. Short shot is an injection molding defect where the molten plastic doesn't completely fill the mold cavity, resulting in an incomplete part. It is cause of low pressure, insufficient material, and blocked gates. So now we move to injection molding defects. Firstly, we have short shot. Short shot is an injection molding defect where the molten plastic doesn't completely fill the mold cavity, resulting in an incomplete part. It is cause of low pressure, insufficient material, and blocked gates. So now we move to injection molding defects. Firstly, we have short shot. Short shot is an injection molding defect where the molten plastic doesn't completely fill the mold cavity, resulting in an incomplete part. It is cause of low pressure, insufficient material, and blocked gates. So now we move to injection molding defects. Firstly, we have short shot. Short shot is an injection molding defect where the molten plastic doesn't completely fill the mold cavity, resulting in an incomplete part. It is cause of low pressure, insufficient material, and blocked gates. So now we move to injection molding defects. Firstly, we have short shot. Short shot is an injection molding defect where the molten plastic doesn't completely fill the mold cavity, resulting in an incomplete part. It is cause of low pressure, insufficient material, and blocked gates. So now we move to injection molding defects. Firstly, we have short shot. Short shot is an injection molding defect where the molten plastic doesn't completely fill the mold cavity, resulting in an incomplete part. It is cause of low pressure, insufficient material, and blocked gates. So now we move to injection molding defects. Firstly, we have short shot. Short shot is an injection molding defect where the molten plastic doesn't completely fill the mold cavity, resulting in an incomplete part. It is cause of low pressure, insufficient material, and block. The next is flash, a thin unwanted layer of plastic that leaks out of the mold cavity and solidifies on the finished part. It is cause of excessive injection pressure, wound mold, and poor clamping force. The next is sink marks. Seam marks is depressions on the surface of injection molded part, typically found in thicker areas caused by material shrinkage as it cools and solidifies. It is caused of uneven cooling, thick sections, and low packing pressure. The next is well line. Well line is visible lines on a plastic part where two or more molten plastic flow from meet and fail to fully bond and knit together. It is caused of low material temperature, poor venting, and improper gate design. The next is warp edge. Warp edge is a distortion or deformation in plastic of a plastic part after it's ejected from the mold, caused primarily by uneven shrinkage rates and internal stresses. It is caused of uneven shrinkage and improper cooling rate. The next is burn marks. Burn marks is discoloration, often black or brown, on the plastic part caused by trap air or gas overheating and scorching the plastic. It is caused of poor venting and very high injection speed. The next is voids. Lastly is voids. Voids is internal air pockets or cavities that form in injection molded part due to the material shrinking internally. It cools. It is cause of insufficient packing pressure, trapped gas, and fast cooling. So now we move to preliminary factors of mold design. First, short weight. Short weight refers to the total weight of molten plastic material required for the cycle, including the part, weight, and runner system. Next is clamping necessary. Clamping is the process of holding the mold tightly together during injection. Next is molding cycle, the total time of one complete molding process: injection, cooling, and ejection. Next is family mold. A family mold is a type of mold that has two or more different cavities within the same mold base, allowing different parts and usually part of one assembly to the produce in a single injection cycle. Okay, next is position and type of feed. The feed system in injection molding is the path through which molten plastic flow from the injection unit into the mold cavity. It includes the sprue, runner, and gate. The position and type of feed are very important to ensure the part is filled evenly and without defect. And lastly is number of impression to be included the tool. It is refer to how many cavities are in the mold, single or multi-cavity. Okay, next we move to type of injection mold. First, two-plate mold, the simplest type of plastic injection mold, consisting of two plates, a fixed A side and a movable B side. that separate along a single parting line. Second is triplet mold. Triplet mold is a type of injection molding tool used for producing complex plastic components, often with multiple cavities. Unlike a simpler two-plate mold, it uses two parting planes and has an additional plate to separate the molded part from the runner system automatically. So this is my complete mold design. This is for core design and cavity design. So this is for mold design and product design. Okay, now we move to discussion. The mold design made in this project use a two-plate system because it is simple, strong, and easy to use. The design includes the main part such as the core cavity, sprue, runner gate, ejector pin, cooling channels, and guide pins. Each part has its own function to make sure the mold works properly and produces good quality parts. The core and cavity were designed to form the shape of product accurately. Lastly, conclusion. This project successfully explained the process of injection molding and the steps involved in designing a complete mold. The study covered the important factors that must be considered, such as clamping necessary, mold cycle impressions and gates, as well as the common defects that may occur during production. The design focused on a two-plate mold system because it is simple, cost-effective, and widely used in industry. The final mold design included the core cavity, ejector system, cooling channel, and so that's all from me. Thank you.